In example 2, we are looking at the population of a state. We are given the population of Oregon in 2010, and then we are given the population of Oregon in 2014. So 4 years later, we're looking at the population change over time. Notice it does look like the population increased. So I would expect my rate of change to be positive because I'm going from 3.8 million to about 3.9 million over that 4-year time period. It's asking me to find the average rate of change of the population over this 4-year period. So you're going to have how many people did it increase and decrease over time. And then we're going to use that slope to predict what the population will be 10 years from 2014. So let's start with the first part of it. What's the average rate of change here? Now notice my slope is not going to be a ratio this time because my units are different. I am looking for how many people per year, per whatever the time increment is. That's what I'm looking at. So the change in the number of people over the change in time. Units different, people versus years. So to solve for this, I'm going to put on top my population. You could think of it this way. My X1, Y1 would be the year 2010 and a population of 3,831,000. And my X2, Y2 would be the year 2014 and the population of 3,970,000. It's a lot of commas. It's sort of weird to look at it that way because I have the comma in the middle and then all the commas in that big number. But I am basically finding the slope or the change, rate of change of this with using this formula. Now I made the population Y and the time X. We tend to always put time on the bottom or almost always put time on the bottom. But you're looking at what's happening here with the changes. So I ended up with 3.9 million and some change and started at a population of 3.8 and some change. So if I subtract those, I get the difference. It looks like the state of Oregon increased 139,000 people from 2014 to 2010, which that's a nice enough number. I know that that is 4 years. Again, notice my units are different. This is how many people per year. That gives me a total increase of 34,000 if I do the division. 34,750 people per year. That is my population growth, approximately. Now they're asking me to use that to predict what the population is going to be in 2024. So I know every year it's increasing, assuming that the growth stays constant, that they continue to increase in the same amount that they have for the past 4 years. In the next 10 years, I know that every year for 10 years, the population will increase. Need one extra zero. So over 10 years, that is 347,500 people to be added to where we left off, right? The population in 2014, because we're looking at 10 years after that. So I'm going to add 347,500 people to the 3,970,000 people were there in 2014. So all together, if I add that all up, that gives me a total estimated population of over 4 million in 2024. So 2 parts of the question. 1, you're calculating the average rate of change. It's important that you get the units in there. The number isn't meaningful without them. And then what you're estimating the population is going to be 10 years later.